Today we're going to talk about data sets. This is a very vocab-heavy lesson, but there isn't much math, so for those of you that prefer the vocabulary, it's going to be a lot easier for you. This is going to be kind of an intro to sequences and series and other things having to do with data. So what is data? Data is factual observations or measurements that are used to create knowledge. You have different types of data: qualitative and quantitative. Now, qualitative can also be called categorical. Why? Because it describes the category that a piece of data falls into. I like qualitative a little better because it describes the quality of something. It's data that describes a feature. For example, the book is red. What type of book? A red book. Quantitative data has more to do with numbers. It's data that involves numbers. How many books are there? There's 12 books. How long is the book? It's 100 pages. There's a specific quantity to quantitative data. Qualitative data is more subjective. Next, a census versus sample. A census takes data from every single object in the population. So we just had the census in the United States, where they asked questions of every single person in the United States in order to get their data. A sample, on the other hand, takes data from a portion of the population. So when you hear about surveys, who you're going to vote for, those are samples. Only part of the population is answering that, and they're assuming that the rest of the population is going to go along with those same answers. Next, we have discrete versus continuous data. Discrete data is quantitative data that involves distinct, separate values, whereas continuous data is quantitative data that involves an infinite amount of values. So we'll do a few examples to really hone in what each thing means. First, the instructions. Qualitative and quantitative data both have their importance. Generally speaking, quantitative data tells you what is going on, and qualitative data tells you the why it is going on. So let's go through a few of these, and it should become pretty clear the difference between qualitative and quantitative. The person has brown eyes. Well, that's a quality of the person. If it's a quality of them, describing them, then that would be qualitative data. The bank has $3.2 million. Well, that is a very specific quantity. So that would be quantitative data. The group is from Croatia. This is describing a quality about the group, where they are from. There's no numbers attached, so it is simply qualitative. There are 95,000 people in the city of Menifee. That would be a specific number, a quantity of people. There are 15 people in the class with brown hair. Now this can be a little bit tricky. Are you talking about brown hair, or are you talking about the number of people? Well, here we're counting the number of people that have brown hair. So this would be quantitative because we're dealing with the number of people. Brown hair is the quantifier. Like before, we said 95,000 people in Menifee. We didn't say that it's qualitative because they're in Menifee. We said there's quantity of people. Here we have a quantity of people with brown hair. So it's quantitative. The person lives on Han Road. This is describing where that one person happens to live. Not how many people are there, but where that person happens to live. That would be qualitative. Now moving on to discrete versus continuous. If the data is the concept of time or is measurable, then it is usually continuous data. If the data is counted, then it is generally discrete. So let's look at some examples and it should become clear. We will measure the time it takes for each student to stand up from their desk. So stand up and I get a stopwatch. Is this discrete or continuous? Well, think about it. One person takes 1 second, another person takes 2 seconds, another person takes 3 seconds. Well, we have numbers anywhere between 0 to 3 seconds. So that sounds pretty discrete. But it's not. It's continuous. Why is it continuous? Well, think about it. I can have 0.5 seconds. Maybe someone's a little slower and he took 2.5 seconds. And then someone comes in with a slow motion camera and they says, hey, I can help you. And it's not 2.5 seconds, it's actually 2.356 seconds. So in reality, on a number line, between our starting at 0 and our stopping at 3 seconds, there's actually an infinite number of times between 0 and 3. It's not 1, 2, 3. It's not 1/2 and 1. It's not 1/4. We can keep going on and on and on for a decimal. So like we said at the beginning, the concept of time is continuous because we can become more and more accurate adding on more decimal places, which makes it an infinite number of possible answers, which gives us a result of continuous. Moving on, we are going to count how many people are on a specific plane. Well, most planes hold somewhere between 300 people, so the plane might be completely empty or it might be completely full. Because we're talking about people, we can't say that there's 200.5 persons. We don't have half of a person. We can't say that there's 145.75 of a person. That doesn't work. You have to count people as individuals. So you have 100 people on the plane, or 101 people, 102. So if we're going to count how many passengers are on a specific plane, we need a discrete number of people. So the answer here is discrete. We are going to measure how tall a tree is after each year. So may those specific trees can grow all the way up to 150 feet tall. And we start measuring. In the first year, they're at 10 feet, and then it's at 20 feet. And those sound pretty discrete. But then someone comes up and says, well, wait a second. Your tape measure only has feet on there. What about the inches? You say, oh, well, it's actually 10 feet 6 inches. And someone else says, well, wait a second. 6 point what inches? Because we're measuring, again, we can go down into decimals and continue measuring smaller and smaller. So if you're measuring something like this, then you can say it is a continuous measurement because there's an infinite number of possibilities between 0 and 150. Next, we're going to record the angle that a rocket is propelled into space to orbit the moon. So we have the ground, and we have the rocket, and he's at a specific angle. And so they want to know what the angle is. Well, is it 1 degree, 2 degrees, 3 degrees, 4 degrees? Or is it a portion thereof? So think about it. Is that a 30-degree angle? Or is that a 30.1 degree angle? Or a 30.0001 degree angle? When you're talking about launching something as far away as the moon, then a tiny, tiny change down here will make a giant change out there. So this is going to be a continuous measurement. Again, measurement, continuous. Our last example, we're going to make a list of how old each president was at their inauguration. So when they were brought into the presidency, how old were they? Now you could say, well, he was 68.321 years old. And someone else says, well, no, I know that he was 68.3121 and 15 seconds old. That's not how we usually talk. If you're 18, I ask you how old you are, and you tell me I'm 18 years, 3 months, 2 days, 5 hours, and 51 seconds, we would all look at you with a strange look, knowing that you're obviously making things up. We typically count years or ages of people in whole numbers. So one president's 68, the other president was 47, the other president was 59, the other president was 71. These are specific, discrete years. We're not going to count decimals when asking how old a person is. So this one is going to be discrete.